well recovered, well recovered. And
no.
Okay, look here.
Yeah, we can on the light that one.
Not the light.
Yeah, we can see this.
You can see this.
Yeah, right. Our iPhone is so stuck.
So this is the elasticity. But for the elasticity, it means that when we put load on the material, we want the spring will develop like this. And this is when we release the load. When we release the load, the permanent deformation. Yes, okay. The permanent deformation will return. So basically, elasticity. And then what is breakness and hardness? Breakness and hardness. For the breakness, it means what? For the breakness, it means the strength is very small. String is very small. And when the load is up to some, up to maybe the limiting load, the brake will happen. It will not be break. It will not be broken. Yeah, it will not be broken. So this is for the breakness. And many kinds of materials in civil belong to this kind of breakness, this kind of breakness, such as iron, rock, brick, glass, concrete. They are all belong to have this kind of breakness. And for the toughness, it means that the deformation is big, and it will not be broken, and it will not be broken. So the deformation, it will keep and then we can learn something about the water, the properties of materials about the water. Why we need to pay attention to this problem? Because most of the materials we use in civil engineering are contact with the water, such as the moisture in the air or the underground structures under the ground, under the water. So we need to know what is the hydrophobic and hydrophilic and hydrophobic property. We need to know this angle to decide what it belongs to. Yeah, if the angle below 90, yeah, the angle is below 90, it belongs to hydrophilic. Yes, hydrophilic. But if bigger than the 90, it belongs to the hydrophobic material. And such as the stone, brick, concrete, cement, aggregate, glass. Yes, glass. Yeah. And then the wax, asphalt, plastic.
Yeah,
belong to the hydrophobic. Hydrophobic.
Wood.
And the wood. Yes, and the wood. And for the open absorption, last time we have noticed the difference of the specific absorption of the mass and water percentage. For the same material, the specific absorption of mass is solid. It cannot be changed. But because it is immersed into the water, but for the water percentage, it relates to the moisture of the air in the air. So if the moisture is high in the air, the water percentage is also high. If the moisture in the air is low, the water percentage is also low. So it can be changed by the air. It can change by the natural condition. And then most properties of wet materials drop or get worse. That is, the strength will decrease. And so the sound absorption will decrease, and corrosion will decrease. Resistance to freezing and thaw also decrease. So we need to get the material to have this kind of water resistance, and the impermeability. The impermeability means the materials resist the pressure water. Because last time I have this. So this structure is a concrete structure. Yeah, this is the water, and the first place, second place, third place. Because the pressure here is very big, so the permeability of the water is big, and the impermeability is bad here. Especially for the underwater structures or structures in the water, the impermeability is very important when we select the materials. And how to evaluate the impermeability? We need to get this penetration coefficient or penetration degrees, especially for the penetration degrees. We need to know. This is the penetration, and maybe this is the number, such as 2, 4, 6, and so on. What does this mean? What does this number mean? It refers to the hot pressure. Yes, hot pressure. So this is penetration and how to evaluate how to evaluate the impermeability. Another one is the freezing and thawing resistance. Because when the water is when the water at the low temperature, it will become from the liquid state to the solid state, and the volume of the water will expand and slightly. So we need to get the freezing and thawing resistance. And for the thawing and freezing and this is freezing, okay? And this is the number. So what does this number mean? This number means the circles, yeah? The freezing, thawing, one circle, yeah? And then freezing and thawing. So this is about the way we can learn last time. What we have learned before all belong to the concepts which is suitable for all kinds of materials. And from today, we'll study some typical materials in civil engineering, such as the aggregates, cement, the lime, the gypsum, and asphalt, concrete, and steel. So today firstly we will study some properties about the aggregates. So firstly, I want to ask you a question. Maybe What is the difference about this? What is the difference between the rock and the aggregates?
This rock is natural and we can get aggregate from rocks.
Yes, great. We can get aggregate from the rocks. Yeah, difference. What is the difference?
Because we
What-
modify
what's the difference?
aggregate, we modify
Modify,
Size.
modify.
The size.
It can be modified. The aggregate can be modified from the rock.
yeah.
And what the modifying means?
This rock we break the rocks
Yes, break the rocks.
and then we get
We can get the aggregate.
Yeah.
So the most important
The size.
difference is what? The
The size.
Yeah, the size. The size. The size of the rock is big. Yeah, it's like this one, it's this one, it's like this one. Yeah, this is the rock. We can get it from the mine, from the mountain, or underground. Yeah, we can get this kind of rocks. But for the aggregate, what is the aggregate? Aggregate means aggregate refers to the materials we can use in concrete, especially in the cement concrete and asphalt concrete. But in this kind of concrete, the size of the aggregate mostly below how many? The size mostly below how many? Can you imagine? The size of the aggregates used for the concrete mostly below how many? No? 40 micrometer. How about 40 micrometer? It's just like this. Yeah? 40 micrometer, not centimeter. Centimeter maybe like this, 40 centimeter like this. 40 micrometer. Yeah, that's like this. So,
luckily on the road we use big size.
yes, yes. This is rock. But we cannot use the big size aggregate.
Not
in
big,
concrete.
more than 40.
More than the 40?
Yeah.
You mean just like this one?
No.
This one?
Yeah.
This one, how maybe 50?
No.
So I said, mostly, okay?
Oh yeah.
Mostly, not all. Mostly is below 40 micrometers. So I need to know the classification of the aggregates, the typical properties of the aggregates and the gradation. Okay, we should pay attention to this concept, gradation. The gradation is very, very important for the aggregate when we use it for the concrete, because the size of the aggregate is required, is mentioned for the application of the aggregate. We cannot use the aggregate not because we need to get the gradation and gradation of it. So for the aggregates, first we need to get the classification of it. How about the classification of the aggregate? Maybe the first one we can based on the method of manufacture. The first one we need to know. We can get two kinds of aggregates. What two kinds of aggregates? The first one is from the nature. Yeah? This nature material just such as the pepper, such as the sand. It belongs to the natural materials. Yeah? And then we can get the aggregates from the crushed stone. The crushed stone, the crushed sand. It can be produced by the machine, as a crusher. So, the first we can, based on the method of the manufacture, we can divide them into the natural aggregates and the manufactured aggregates, or crushed aggregates. And second, we can, based on the size, the aggregates can be divided into two kinds of aggregate from the size, by the size. By the size, it can be divided into fine aggregate, and then coarse aggregate. So the critical size is 5 micrometer. If the aggregate, the size of the aggregate is bigger than 5 micrometer, it belongs to the, if the size is bigger than 5 micrometer, it belongs to the coarse aggregate. Yes, 5 micrometer. But if it's below 5 micrometer, it belongs to the fine aggregate. So what is the coarse aggregate and fine aggregate? The size bigger, it is coarse aggregate. What are the functions? Well, explain to this, okay? And then we can get the classification of the aggregate based on the density. Maybe just like we have the normal weight, the light weight, and the heavy weight. From the density of the aggregate, and then we can get classification of the aggregate based on the source. We can get the primary aggregate and the recycled concrete aggregate. What is the primary aggregate? What is primary aggregate? Just like this one. Okay? Natural aggregates, manufactured aggregates are all belong to the primary aggregates. Primary. They are firstly built in the civil engineering. But for the recycled concrete aggregates, it means if we, maybe 20 years ago, we have constructed this road with grade, with aggregates. But 20 years later, the road is broken. Yeah, the road is broken. We need to fix it. Yeah, we need to fix it. And during the reconstruction, we can use this kind of recycled concrete aggregates from the older roads. Yeah, we can from them. So
controversial is definitely will be good.
Oh. Can you?
Which we use recycled concrete.
This one? This one? You mean the knife? The knife of the yeah. Maybe we need to know we cannot use all of the aggregate recycled aggregates. Maybe we can just add 30%, 40%. Yes, yes. And mixed with the fresh aggregates, just like the primary aggregates. Mix them. We cannot use 100%.
Please be careful.
Yeah.
Well, this is about the classification of the aggregates.
That's it. What about big ships?
Big
Ships. Sometimes we use big ships as aggregate. Brick. Yeah. Brick.
Oh, you mean brick?
Yeah.
For the brick, the aggregate, the size of the aggregate is small. Yes, it's very small. Maybe we even cannot find the coarse aggregate in the bricks. We can't. Yeah. For in China, maybe the size of the aggregate used for the brick is very small. Always below. Always below the 5.
In our country, when we make road, first time we use and then we roll the this one, and then we use stone
Great. This is for the base of the road. Yeah, we can even use the rocks. We can even use the rocks for the base of the aggregate because the strength of it is very big. Yes.
Rock is not
You use this one, yes. Okay. But it's not. But I also think it all belongs. It all that belongs to the brakes, not brakes. This one is brakes.
Actually, sometimes we use the normal road as a local road. The local road.
Maybe there is some difference from the definition of your brakes and my brakes. Man-made brakes. Man-made brakes, the size is just like this. Okay, in this, maybe in this size of brakes, the size of the aggregate cannot be too big. Cannot be too big. Because the size of the brake is also limited. Yeah, maybe the thickness of it, like this one. So we cannot, yes, we cannot use too big size aggregates for brakes.
Not the friend aggregate size, the small the size is millimeter or micrometer.
Millimeter. Yeah.
It's supposed to be 500.
Millimeter.
Oh, yes, I just the micrometer, yes, I understand. Millimeter, yeah, millimeter. Yeah, yes. Oh. Okay, for the technical properties of aggregates. For the technical properties of the aggregates, maybe we need to know the moisture level, parking, strength and softness, parting shape and surface texture and impurities. So the first thing we need to know what is the moisture level. Because what we have learned before, the the percentage of the aggregate used in the concrete is big, maybe 90%, maybe 80% will belong to the aggregates. So this is the stage based on moisture level of aggregates. The first one is the open drag. So what is the open drag? We can look at this diagram. What is the open drag? It means this is an aggregate, and there are some pores. Yeah, this is pores. This is pores. There are some pores in the aggregate. So from this diagram we can find that there are no shadow. Yeah, no shadow in this aggregate. It means there is no moisture. There is no moisture in the pores.
Yes.
So this is the open. And then this is the air dry. What does air dry means?
Air dry.
It means there are some moisture in the pore. And the moisture is equal or equivalent to the air outside. Okay? The moisture in the pore is equal to the air outside. So this is the air dry. And then get the saturated surface. Saturated, what does saturated mean? From this diagram we can find saturated means the pores is full of water. Yeah? The pores is full of water. Yeah? So this is the saturated. And the surface dry. What is surface dry? There are low water here at the outside, at the surface of the aggregate. So this is the surface dry. The last one is the wet. What is wet? The wet means the pores are full of water. Yeah, the pores are full of water, and the surface of the aggregate it also gets the water film. And gets the water film. So these are the 4 kinds of states of the aggregates based on the moisture level. I'll give you a question. For the aggregates we use in civil engineering, what kind of state or states is anchors often we can get? There are 4 kinds of states, yeah? Which one? Or which 2? We can get easy. We can get easy for the aggregate. Okay, for this one, how can we get this? How can we get this state? For the aggregate, we need to put the aggregate outside. We can get a shelter. We can get a shelter. No. It's open. It's open, and then it rains. After the rain, maybe several days, not 1 hour, 2 hours, we cannot get this state. Maybe after several days raining, the soil or the aggregate it gets the wet state because the pores in the aggregate is full of water and the surface of the aggregate gets the water film. This is the wet state. And then, how can we get this state? Saturated surface dry. From this one, we can get the aggregate from outside, inside. And then, maybe we can use the towel to dry the surface. Dry the surface. But we can imagine it. The time of this state is limited. Yeah? We can keep this state. The time of this state is very short. Maybe just half an hour. Maybe just 20 minutes. Yes, one hour. Yeah. So this is the saturated surface. And then the outline. How can we get the outline of the aggregate? If we put the aggregates outside, we need to get a shelter. Yeah? We need to get a shelter. And then the weather is not changing. But maybe it's sunny for several days, or it all is sunny, raining for several days. But it gets shelter, so it cannot be wet. So we can get that. If we put the aggregates inside, just like in the classroom, put the aggregate in the classroom, and the weather is not changing, but maybe it is sunny for a week, and then the aggregate gets out because the moisture in the aggregate is equivalent to the air outside. So this is the air. And then the oven, it is difficult for the natural aggregates. How can we get the oven? We need to put the aggregates into the oven. Yeah, into the oven and heating it. After the heating, the moisture in the aggregate will vapor. So maybe it needs maybe 24 hours. So for the aggregates we used in the construction, maybe this one is
what is the heat level in Celsius oven rate?
what is which one? in the oven, maybe if the heating time is long, maybe just 100 centigrade, yeah, 100 centigrade. If the heating time is short, maybe we can get 180 or 200 centigrade. If the temperature is high, the time will be short. Okay.
So what is the advantage of oven dry acrylics?
What is the aggregate?
Advantage. Why
Why we will get this oven dry? Yes. For what? For the experiment and the construction. Especially for the asphalt concrete. When we first, if we want to construct an asphalt pavement, we need to get the aggregates from outside into the laboratory, and then conduct a lot of experiments to decide how many aggregates needed for the asphalt concrete, and then how about the content of the asphalt needed. So in the laboratory, when we conduct experiments, we must use the oven dry aggregate. And in the field, construction fields, the aggregates may be at this air dry state.
Yeah.
But for the asphalt concrete, they also need to be oven dry. When we mix the asphalt concrete, the first thing we need is to heating the asphalt and heating the aggregate. The aggregates must need to be heated at about 180 centigrade. In this high temperature, the moisture in the aggregates can be disappeared. So the oven dry state is also very important for the application of the aggregate in concrete. So we'll just oven dry, air dry, and saturated surface dry, and the last one is the wet. Your count is the wet. So this is the state based on the moisture. So package. The surface moisture in fine aggregates can cause an increase in the volume. Compared to the dry volume caused by the cooling part of the particles due to the surface tension. So we always need to the aggregate to be dry. Oven dry or air dry. For the aggregate strength. So what are the functions of the aggregate in concrete? It affects what? So this is the concrete. We used a lot of aggregates in it, yeah? And from what we have learned just now, the aggregate can be divided into two kinds of aggregate. One is the coarse aggregate and the fine aggregate, yeah? So this is the specimen of the concrete. Maybe there are a lot of aggregates in For the coarse aggregate, the function of the coarse aggregate is what? The function or the effect of the coarse aggregate is skeleton. it becomes the skeleton of the structure.
Yeah.
It becomes the skeleton of 3. 3 becomes the skeleton of the structure. This is for the coarse aggregate. But for the fine aggregate, the function of it is to fill the voids. Between the coarse aggregate. So is like act just like a finger. So for the concrete, the function of the coarse aggregate is to be a skeleton of the structure. For the strength of the structure, the strength of the aggregate is also very important. So the aggregate should have high enough strength to play the role of skeleton. The skeleton. In cement concrete, and actually means. So how can we evaluate the strength of the aggregate? Maybe we can we can evaluate the strength of the aggregate by 2 methods. The first one is we can get the cubic strength of rocks. Yes, this is cubic. This is cubic. We cut the aggregate into this size. And then we use the compressor machine to get the load, to get the limited load of the rocks, of the aggregate, and then we can get the strength of the aggregate. If the strength of the aggregate is high, the strength of the structure is also high. But this experiment is difficult to conduct. Because this size is difficult to get. It is not easy for us. And then during the experiment, we must put the specimen into the water. Why into the water? Because we need to get the saturated state. So it is difficult for us for the evaluation. We can. This one is easy for us. It calls the aggregate crushing index. So what is the crushing index? Firstly, the strength is mainly for the coarse aggregate. Yeah. In our opinion, what is the coarse aggregate? The coarse aggregate means bigger than 5 millimeters. Bigger than 5 millimeters. And then we put the aggregates into this volume and to compress it. Yeah, to compress it. During the compression, some of the aggregates will broken. Yeah, broken. The size will decrease. The size, some particles get a smaller size. Some particles get a smaller size. So the aggregate crushing index calculated as the mass percentage of the crushed fine particles to the total mass. This is the total mass before the experiment. Before the total mass before the experiment. And this is the after the experiment. The mass we can get of the fine aggregate, because the coarse aggregate, maybe some of the coarse aggregate is crushed into fine aggregate. of the test sample, which bears the crushing load, under some conditions. So, I'll give you a question. If the aggregate crushing index is bigger, it means the strength of the aggregate is good or bad. It's good or bad. It's good or bad. It's bad.
Yeah.
Yes, because the crush is so big. Crush is so big. So this is a very important index for the application of the aggregate. Okay, it's good. I'm afraid that soil recycled and so on. So it is related to the surface aggregate. We can use the direct phase sowing method. The direct phase sowing method is first we choose some aggregate and then immerse them into the water, make them get the saturated state, and then frozen it. After frozen and then soiling it. So one circle by one circle, we can get the direct phase sowing method. But this method or this experiment needs the time is much longer and much time is longer. So it is not easy for us to get. We can use the immerse in the surface solution. Because during the if the solution is saturated, the crystallizing of the surface will occur. It will also get the effect of this expanding effect. And for the particle shape and the surface feature. Particle shape, what kind of particle shapes we can get for the aggregates? The first one is the round, just like the pepper. Just like the pepper, the round. Just like this one, round. They are round. And then the angular and subangular is just like this one. This is the angular, subangular. The round one is especially for the natural material, natural aggregate. And for the crushed stone or crushed or manufactured aggregate, it always angular or subangular shape, get this kind of shape. And then this is needle. This is the needle and flake. So what is the needle and the flake? The needle shape and the flake shape is harmful. The needle shape and the flake shape is harmful to concrete. It's harmful to concrete. Why? Because as we this one. This is a concrete specimen. And in this specimen, we can have different kind of shape of the aggregate. This one is the round one. This is the round aggregate, round shape aggregate. And this one is the needle one, a needle shape. Okay. When we put the load on it, which one will break at first? Which one? The needle one. Yeah, the needle one. So when even the load is very small, the needle one is broken. After broken, what happened? What occurs? Correct occurs. Yeah, correct occurs. And then when we increase the load, when we increase the load, the crack will develop through the specimen. So, if this specimen have a lot of needle shape aggregate, the strength of it is much lower. Is very low. Is very low. So the needle shape and the flake shape is harmful for the concrete. So we need to evaluate the dosage of this control too. Maybe we can get a kind of aggregate, and then we need to find some needle shape aggregates, some flake shape aggregates, and then we can get the method of these two. Yeah, we can use this tool to. This is the mass of the flake shape and the needle shape aggregates. And this is the total shape before the experiment. And then 100%. So if the dosage, if the value is high, it means the shape, the particle shape of the aggregate is worse. Yeah, it's worse. So this is for the particle shape of the aggregate. And then for the surface feature is mean at the surface of the aggregate.
Yes, toughness.
Maybe we can get the smooth surface. What is the surface? Smooth surface. Just for the this one, for the natural material, natural aggregate. Yeah, as the paper. Naturally, the surface of the aggregate is very smooth. It is smooth. And the roughness, what is the roughness? Especially for the manufactured aggregate or the crushed stone, crushed sand, the surface is toughness. And then it's related to the porosity on the surface. If the porosity is big, it always means that toughness. That means the toughness. Okay. So for these two kinds of aggregates, one is a natural aggregate. Another one is that crushed or the manufactured aggregate. And for this one, it gets what kind of particle shape? Round. Okay, round particle shape. What kind of surface texture?
Smooth.
Surface is smooth.
Smooth. Yeah, smooth. Round and smooth. Yeah. But for this one, is angular and
Rough.
toughness. So, if we use these two for the concrete, for the cement concrete, the shape and the surface texture will affect the performance or the property of the concrete. How it affects? Maybe two. And the first one is that working property. What is working property? It means this, like just mentioned. If we want to construct the concrete, firstly, we need to choose several materials, actually the cement, the water, the coarse aggregate, and fine aggregate. Yeah, we decided the content of each one, and then put them together, mix them, and after the mixing, we can get the fresh concrete. Yeah, fresh concrete. This one is a fresh concrete. The fresh concrete is different to what is this concrete? At the ground, at the beam, what do we call this concrete? Hardened. Yeah, because it has strength. It gets strength. Yeah, this is the hardened concrete. But before the hardened concrete, after we mix them and then transfer them into the field and construct it, at this time, we call this kind of concrete as a fresh concrete. For the fresh concrete, the working ability. The workability means it is easy for us to mix them, to transfer them, to construct them. So, in this workability, there is three kinds of parts. And the most important is the flow. Is the flowing of the concrete. So we need to think about if we use these two kinds of aggregates, which one is better for the workability or the flowing of the cement concrete? Which one? The first one or the second one? The first one or the second one? The first one. Because you can imagine the particles is round. And the surface is smooth. So it is easy for us to mix them. The friction is small. The friction is small because the particle is round and smooth. So it's easy for us to mix them.
Yes.
And the flowing property of it is big. Yes. But for this one, it will be
Hard.
it will be worse. The workability it will be worse. So this is for the workability of the concrete. Workability of the concrete for the fresh concrete. And another one is for the we have just hardened concrete. For the hardened concrete, there is a very important property that's like strength. Yeah? Strength. So, if we use these two kinds of aggregates to construct the concrete, for the hardened concrete, which one is better? Which one can get better or bigger strength? Which one? Two. Because it's angular. And the surface is toughness. So the adhesion, do you know what is the adhesion? Adhesion means the cement paste aggregate. They need to contact. Yeah, they need to contact. So if the surface is toughness and the shape is angular, the adhesion is good. The adhesion is good. The adhesion is good. Do you still remember? I have explained to you. This is the concrete. This is the coarse aggregate. Yeah. And how about damage of it? There are three kinds of damage. The first one, the cracks get through the aggregate. The second one is through the statement paste. The third one is the cracks develop along the surface of the aggregate. Which one? There are three strengths. Yeah? The strength of aggregate, the strength of the statement paste, the strength of the surface or transition zone. Transition zone. Which one is the smallest? This one. Yeah? This one. This one. And if we use this kind of aggregate, the strength at here is enhanced, is improved. Yeah? The strength at here is improved. So the strength of the concrete is also increased. So if we use the manufactured aggregate, we can get better strength. But if we use the natural aggregate, we can get better workability. So this is the natural one. Yeah. This is the crushed one, or the manufactured aggregate. So we have expanded here. Yeah. Effects of particle shape and surface feature. Effects of particle shape and surface feature. So for the river side, sea side, mountain side, mountain, and the particle shape for the river side and sea side is what we want elliptical and vector. And surface texture is small. The workability, just we have said, workability. Okay? That is the workability. The workability is well. But the strength is low. The strength is low. But for the mountain sand, what is the mountain sand? You don't know what's the mountain sand? Okay, I can explain like this. It's just a crushed sand. It's a crushed sand. We get the rock from the mountain, yeah, and then crush them. Crush them, we can get coarse aggregate and also fine aggregate. This is the crushed sand. Yeah, crushed. Crushed sand maybe doesn't do this one. Yeah, crushed. So the workability of it is bad, but the strength is high. The strength is high. And the surface texture is rough. And the particle shape is pointing. So, for the impurities of sand, there are many kinds of impurities in sand. Sand is the clay, the cloth, the makeup, and the matter, and organic substance. Organic substance is very important. Especially for the impurities and the sulfate and chloride. So they are all belong to the impurities. They are all belong to the impurities for aggregates. So why we call? Because they are belong to the impurities, it means that they are harmful. They are harmful. Yeah? They are harmful to the aggregate, or they are harmful to the concrete. Why? because what kind of damage? Yeah. The first thing, handle the bond. Handle the bond. What is the bond? That's I said the adhesion. Yeah. The cement paste and the aggregate, the adhesion, the bond. Bond. Handle the bond between the paste and the aggregates. And then weaken the strength of concrete. Why they are weakening the strength of the concrete? Because if there are some impurities at the surface, or if there are some impurities in aggregate, the surface of the bonding, the surface of the bonding, or the bonding area will be break, will be damaged by the impurities. So you can weaken the strength of concrete and increase the quantity requirement of water. You can increase the quantity required or the amount required of the water. And then decrease the shrinkage of the concrete and bring corrosion of hardness. So there are some damages which can be get from the impurities of aggregates. So for the requirements of the aggregate, the first thing we need to know the aggregates for use in concrete must be clean, because in those impurities there is the clay or cloth, so the aggregate must be clean. Clean, hard. Hard means what?
Straight.
Means straight. Yeah? There are no light metals in the aggregate, or net, or nickel, or little light metal. And strong and durable.
Life expectancy.
And then be free of chemical and fine material coatings. The surface is clean. Yeah, the surface is clean. No chemical materials or fine materials. What is fine? What is fine material coatings? Just like the clay. The clay. No, the sand is so big. Clay. Very, very fine particles.
Yeah.
Very, very fine particles. So if the article, the surface of the article, get this kind of, okay? Just for this one. For this one. The surface of the aggregate is clean. Yeah? The surface of the aggregate, the surface of the aggregate is clean. The cement paste, the bond of the cement paste is it's good. The bond between the surface and the aggregate and the cement paste is good. But if there are some fine particles, such as clay, fine particles at the surface, the bond will be worse, will be bad. Yeah? Can you hear for this one? If there are fine particles at the surface, the bonding is not good. And then the fine fractions, such as should not be permitted in large quantities. And the flat, thin, or non-aggregate particles should be avoided. Just like this. Yeah. The little aggregate or the flatted aggregate. The quantity shall not be avoided. No materials, such as the organic matter, expensive material, soft or porous particles. So this is the requirements for the aggregate we can use for the concrete. And then we need to move on. For the gradation. What is gradation? What is gradation? What is gradation? The gradation means the particle size distribution. And the proportions by method of aggregate particles distribute in space particle size range. Such like this. This is one kind of gradation. This is the kind of this. From this one we can find that they are all made by the coarse aggregate. Yeah, made by the coarse aggregate. And then they have some fine aggregate, and this one is and we have a lot of coarse aggregate and fine aggregate. So it refers not only to individual but also to the combined or mixed aggregates, fine and coarse aggregate together. So this is the definition about the aggregates. So how can we evaluate the gradation of aggregate? So what is the gradation? I'll explain one more. Okay. This is the aggregate we use for the concrete. Yes?
Yes.
Just make the charts. But there are some. This size is big. Yeah. This size is smaller. This size is much smaller. So in the mixer, the aggregate mixture, the aggregates have different size. We need to know how about the proportion of this size. How about the proportion of this size? And then this size. The total percentage is 100. Maybe this one is 30%, this one is 40%, this one is 30%. We need to know different size and different proportion of different. So how can we evaluate the gradation of the aggregates? We need to do an experiment. This experiment is the same analysis. Do you know same? What is same? Yeah, for the weight, for the maybe some food, we can use it. Yeah. Just make this one. For the same, we need to pay attention to two parts. The first one, yeah, this is the same. It's about 13 sides. 13 sides. Okay. 13. 13 sides. And then we can use them. How to? When we choose some of the sides of the city, okay, and I get this kind of aggregate, I want to know the accreditation of it. And then I choose some cells, put them together. Put them together. So when we put them together, okay, this is the size of this side, the size of this cell, is 9.5. The smaller is the state, the smaller is the size of the state is 0.075. The smaller is size. Smaller is size. So the first thing we need to pay attention to is that when we put these things together, how about the tens? First thing we need to know, the number of the size is limited. We have low 8 millimeter. We have low 3 millimeter. The size, the number of the size is cannot be changed. Cannot be changed. And then when we put them together, we need to put them from bigger to smaller. The smallest. So if this one is 9.5, this one must be 4.75. This one must be 2.36. We cannot put this one and here. This is wrong. Okay? So, one by one. From here. So, when we put them together, and we need to put the aggregate into the states at the top, at the top. And at the top, because the size is bigger, so the biggest particles will retain at here. And then smaller. So after the experiment, every state gets some particles. Every state gets some particles. So for the first index is the individual percentage. The individual percentage retained. What is the individual percentage retained? For this one, for example, the mass of the aggregate retained here may be 100 grams. 100. The mass of the retained aggregate is 100. The total is 1,000 grams or 1 kilogram. So, how to calculate the individual percentage retained? Yes, it is very easy. Yeah, if this is 200, then very easy. Okay, the first one, this is the individual percentage retained. Second one is the accumulative percentage retained. So this is point, the accumulative. It was this one. It means the individual percentage retained at this size, and bigger than this size. If the size is bigger, it will move up or move down. If the size is bigger, up. Yeah, but there is no stage at top. Yeah, so the accumulative percentage retained equals to the individual percentage retained. But for this one, for this side, the individual percentage retained at this size is yes, and above this size. Above this size is this. Above this size is this size. Yeah. Yes. For this one, the individual percentage retained at this size is 3. Yeah. And above this size, two sides. Yeah. A2, A1. For this one, is A4, A3, A2, A1. Oh. Yes? Yeah. So this is the accumulative percentage. The last one is the passing percentage. The passing percentage, because for this one, for the accumulative percentage retained, it means what is retained at here, what is retained at here and here. For this one is retained at here, here, and here. So the passing percentage is 100 to okay. This is the passing percentage. So after the same analysis, we can get 3 kinds of index for each size. Yeah, we can get 3 kinds of size, 3 kinds of index, 3 kinds of index for each side, and then we can get the derivation of this kind of aggregate. How can we express it? The first one, we can use the table. Okay? We can use the table. This is the size. This is the passing percentage. Millimeter percent for line 25. This one, yeah. this is the first method we can use for the aggregation of the aggregate. This is a table. And then we can use the diagram. This is the diagram. And here is the size. This is the size of the thing. Also that. Maybe you can get from here to this direction, the size will be bigger. Yeah, maybe here is the most is the smallest, and then
biggest.
this is the size, and we can get the passing percentage of each side, and then because this side is the smallest, so the passing percentage is also the smallest. Yes, because it is the smallest. So then here and here will be like this. So, at the maximum size, the percentage will be how many? At the maximum size. At the maximum size, the percentage will be how many? 100%. Yeah, 100%. So, this is the gradation curve. This is the gradation curve of the gradation, of the aggregate. However, maybe we have some another. This is the passing. This is the pass percentage. This is percentage. But maybe we can use the accumulative percentage return. But the direction of the size is the same, but the direction of the curve is changing. How is that? Yes? This is for the accumulative. Yes, for the accumulative percentage return. And this is the passing percentage. This is for the accumulative percentage return. So we need to know the relationship between these three kinds of index.
In this saving process, in which we can find good doing this saving process, in which we can put any
You wait what?
basic after this process. We see we can find good and ideally.
Which you can find good aggregate. What does good aggregate mean?
The means size of
No. It's not. We cannot find what is good, what is bad, what is bad.
meaning is
Okay, crossing the road. Okay.